Hello everybody and welcome back to Advanced Maths. Today we're looking at differentiation, optimization. So what is optimization? Well, in maths we have functions, and functions can have turning points. We can see two turning points on the screen where these red dots, the red crosses are. Turning points are maximums or minimums of functions, and maximum and minimums are a way of optimize things. To get the maximum profit in a business, or to get the minimum amount of fuel consumption in a plane, you need to optimize things. And we optimize things by finding the turning points, and turning points are when the gradient is 0. Look at the dotted line at the red crosses here. That is the tangent, and the gradient of those dotted lines is 0. They are flat. So we can find turning points by finding when the gradient is 0. We need to find when the gradient is 0. So to find the maximum minimum, find when the gradient is equal to 0. And to do that, we'll find the equation for whatever it is. And it must be an equation with only one variable. So we can't have lots of different letters flying around. We need one letter on each side of the equation. Then we'll differentiate, and we'll make the derivative equal to 0. And then we'll solve for x. And this is our general process we'll see in today's video. Find an equation, differentiate, make the derivative equal to 0, and solve for x. In step 1, I'm emphasizing that you need to make the equation in only one variable. Now, example 1. It says a rectangular photo frame has an area of a centimetres squared. The width of the photo frame is x and the height of the photo frame is y. The perimeter of the photo frame is 72 centimetres. Find the maximum area of the photo frame. So here we have a quick sketch of what that might look like. We have a photo frame, x across and y up. And we need to maximise the area of the photo frame, given that the perimeter is 72 centimetres. So you can see the 72 is like a constraint. It limits the size of x and it limits the size of y. And we want to maximise the area given the perimeter is 72. So step 1, we're going to find an equation for a in terms of just x. So here we have to remember that the perimeter is 72 and opposite sides are equal of a rectangle, so x and x, y and y. The perimeter will be given by x plus y plus y, or 2x plus 2y. That's an equation for perimeter, and it is equal to 72. Now what we can do is can rearrange this. Can take 2x off both sides, and then we'll divide by 2, and we get 36 minus x equals y. Okay, we've got an equation connecting x and y now. And that's useful because now I want to find the area. And I've got area is given by x times y, base times height, like this. But this is an equation in 2 variables. I only want one variable. So what I'm going to do is I'm going to do something clever. I'm going to replace the y with 36 minus x. And I do this. So area is given by x times 36 minus x. And now I've got an equation with only one variable. And I'll just simplify that by expanding the bracket. And so step 1 is completed. I now have an equation of a in terms of just x. So we can imagine this on a graph, and you have some sort of quadratic graph like this. And this equation here reaches a maximum somewhere. So we maximize the area somewhere. So we're trying to find the x value that maximizes this area. So let's see this in action. Now we're going to differentiate a and make it equal to 0. So we'll differentiate it. And we'll differentiate a, we get dA over dx. And it looks like this. dA over dx is 36 minus 2x. If you don't know what I just did, you need to revise differentiation and to watch my video on differentiation, which I'll link in the description below. If that made sense to you, we're okay, we can continue. We have differentiated this, and this is because we want to find a gradient, an equation for the gradient, and we want to make that equal to 0. So now we're going to make that equal to 0. 36 minus 2x equals 0, and we're going to solve this equation. Add 2x to the other side, so we get 2x equals 36, and divide by 2, we get x equals 18. This is the x where the maximum or minimum occurs, and in this case it's a maximum. So x equals 18 is where we maximize the area. Finally, step 3, we're going to find the maximum area, and we can do that by using the area equation we've already found. So we know that area is equal to 36x minus x squared, and we substitute x equals 18 into this equation. Like this. We replace all the x's with 18, and we get this, which we type into our calculator. And we get 324 centimeters squared, and that means the greatest possible area of this photo frame with a perimeter of 72 centimeters is 324 centimeters squared. Okay? If you have a slightly different x, you'll have a smaller area. So the maximum possible area is when x is 18, and that largest area is 324 centimeters squared. We have finished. That is the end of example 1. So step 1, in the yellow, we made an equation for the area in terms of just x. Step 2, in blue, we differentiated that and made it equal to 0, finding that x is 18. And step 3, we substituted 18 back into the equation for area to get that the maximum area is 324 centimeters squared. That's example 1. Let's look at example 2. A rectangle ABCD measures 7 meters by 11 meters. Triangle AFE is shaded inside the triangle. You can see AFE here is in blue. E lies on BC, x meters from C, as shown on the diagram. F lies on CD, 2x meters from C, as shown on the diagram. Find the smallest possible area of the triangle. So we're trying to make this blue triangle as small as possible. And what we'll do is we'll first find an equation for the blue area by looking at a big rectangle minus these 3 red triangles. So we're trying to find an equation for the blue triangle, for the area of the blue triangle. And here I've got the big rectangle is 7 by 11, and then I've got 3 red triangles that I can find an equation for. And when I do the big area minus those 3 areas, I get the area of the blue triangle. So let's start with this orange triangle, and that is 7 meters up and 11 minus 2x across. Just look at that, 11 minus 2x. I got that from seeing that the full length is 11 and it's 2x on top. 7 times 11 minus 2x divided by 2 is the area of this triangle, base times height divided by 2. Next I've got this orange triangle here, which is 2x times 7 minus x, and I divide that by 2, like that. And then finally I've got this triangle down here, which is 11 by x divided by 2, 11 times x divided by 2. So therefore I can do the area of the big rectangle minus these 3 areas like this. That is a complicated equation, but don't worry, I can simplify it. So I've got this equation and I'm going to expand the brackets like this. Now I've got a 7x and a minus 7x in the middle, and they will cancel like this. And I've got 77 minus 77 divided by 2, and that cancels. 77 minus 77 over 2 is just 77 over 2 positive. So everything we've done so far is just to make an equation for the area in terms of just x. That was some complicated algebra, I agree. It was complicated, but I think it should be achievable for you guys to understand how I got there. If you didn't understand my algebra to that point, just rewind and watch it one more time. Now I've got an equation for area and I can differentiate it. So I'll differentiate this and I get dA over dx is 2x minus 11 over 2. And this is the derivative. This tells me the gradient, and I want to make this equal to 0 at maximums or minimums. So I make this equal to 0, move the 11 over 2 to the other side, and divide by 2. I've got x is 11 quarters. And so we made derivative equal to 0 and solve for x. We're doing good. That is the x value that gives me the smallest possible area. Next, we are going to use that to find the area of the triangle. And so we'll substitute that value of x into the equation for area, which is at the top of the screen. And we'll substitute that in like that. And we'll evaluate that using our calculator. And we get 30.9375 or 30.9 when we round it to 3 significant figures. That is the final answer. We have found the smallest possible area of the triangle. So, step 1, we found an equation. Step 2, we differentiated it and made it equal to 0. Then we solved it for x, and then we substituted that x into the equation to find the maximum possible area. That is example 2 completed. Now let's look at example 3. The radius of a right circular cylinder is x centimeters. The height of the cylinder is 800 over pi x minus x centimeters. The volume of the cylinder is V centimeters cubed, and we're asked to find the maximum possible volume of V. Give your answer correct to the nearest whole number. So you're going to find an equation, differentiate it, make it equal to 0, and solve for x. And this is the cylinder in question. We're just going to draw a quick sketch so we have a really clear idea of what we're talking about. We now need to find the equation for V. And so V will be given by pi times the radius squared times height. That is the equation for the volume of a cylinder. The radius will be x and the height will be 800 over pi x minus x. We can substitute those values in like this. Now we have an equation for volume just involving x. We can expand that bracket like this, and we can simplify, and we can cancel out some x's. Wonderful. We now have an equation for the volume just in terms of x. The pi is just a number, so although it looks like a letter, it is actually just a number, 3.14, so we treat it just like a number. Now, we differentiate. We differentiate v, and we get dv over dx is 800 minus 3 pi x squared. We have differentiated. And now we can make that equal to 0. We rearrange to solve for x. Like this, divide by 3 pi, and square root. And we found an equation for x. Turn it into a calculator and you get 9.21317 ... To find the maximum volume, we're going to substitute that into the equation for V, like this. And when we type this into our calculator, we get 4,913.694, and to the nearest whole number, as it says in the question, is 4,914 centimeters cubed. That is the final answer. That is the maximum volume. Now, some of you probably are wondering how I know whether this is maximum or minimum. And if you are ever asked to prove whether it's a maximum or minimum, you have to do another test on top of that. That won't be in today's video. I will cover that in a future video. For today, I just wanted to show you the general process for optimizing things, finding the maximum or the minimum. Thank you so much for watching today's video from Advanced Maths. Remember to like and subscribe to support the channel. We are creating lots of content for GCSE, A-Level and IB Maths with quick and simple explanations, and new videos are coming very soon. Check out advancedmaths.com for lots of revision resources on these topics. Thank you for watching and good luck in your exams.